We're going to start by talking about vectors, and to do that, we need a little bit of vocabulary. So, the first thing I want to talk about is scalars. So, a scalar is going to be any number that doesn't really have a direction. For example, if you drove 5 miles from your house, but we have no idea which direction you went. So, think about if you drove out your driveway and you made a right versus if you drove out your driveway and made a left, you would end up in two very different places. So the direction does matter. The scalar is just going to tell you how far, and then the vector is going to both tell you distance and direction. So vectors are numbers with a direction. For example, you started at Apple Farm and you drove 15 miles south on Highway 101. We would be able to find you. So, vector anatomy. The head of the vector is the pointy part of the arrow, and the tail of the vector is the non pointy part. Um, the magnitude of the vector is just how long is that arrow. You can talk about the magnitude of the velocity, which is just going to be what is the velocity in terms of like what that number is, and you don't care about direction. Um, every time you see magnitude, just think how big is it? So we can talk about magnitude of the velocity, the magnitude of the distance. We can talk about magnitude of the height, magnitude of the sound intensity. Um, it doesn't tell us anything about direction. It's just how big it is. When we talk about the direction of the vector, it's typically between the vector itself and the horizontal being like the x-axis. Um, so we'll do an example. So if a dog walks 10 meters east and 17 meters north, and I want to know the displacement from where they started and the angle of that net displacement. So here I have my arrow going to the right. So this is going to be the 10 meters east that the dog walked and 17 meters north. And so then this resultant vector is going to be if I added these two together. But if you remember with triangles, you can't just add 10 and 17 together. You actually need to use trigonometry. So when you talk about this happening, if I want to find that hypotenuse of these two vectors, what I need to do is use Pythagorean theorem, which is a squared plus b squared equals c squared, where c is always going to be my hypotenuse. A and b, it doesn't matter which one's which. These triangles in physics, just if it looks like a right triangle, just it is. Don't worry about it. I know in math class it has to be written, but in this class it does not. So I'll do 10 squared plus 17 squared because those are the two sides. And then this c squared is my hypotenuse. So I plug this into a calculator and I solve for c. So that's going to be my hypotenuse. So here I get 389. I square root both sides and I get 19.72. I do not have to do the plus minus thing because I know it's going to the right and up. So I should get a positive number. The second part of this is finding the angle, and the angle is going to be right here. That's theta. So tangent I am going to use because this is adjacent to that angle and this is opposite. And so I know I need to use tangent. And tangent of theta is opposite over adjacent. So opposite being the 17 and adjacent being the 10. And so I take the inverse tangent of both sides, type that into my calculator, and I get 59.53 degrees. And so this is going to be the angle right there. And we're done.